In this video, we're going to continue our study of the labor and capital model, and we're going to introduce some of the important terminology from economics. In particular, the marginal productivity of labor is a concept, along with the marginal productivity of capital. And these ideas capture the extra amount that would be produced if W were increased by 1. So the idea is if we had one more worker, what would we get in terms of productivity? If we increased our capital by one more unit, how much more production would we get? And the word marginal is related to the small change from the current level. So this actually has a nice derivative interpretation because we can look at this change in production over the change in workers as being approximately equal to the derivative of the production with respect to workers. This connection to the derivative is reinforced when we think of this change of 1 is typically very small to the number relative to the number of workers, say, in a large factory or the workforce. So we can approximate it with that microscopic change that is involved in the derivative. What this means is we can translate that marginal productivity of labor, or the increase in production from one more unit of workers. That concept can be captured by the partial derivative of quantity or production with respect to workers, and exactly the same way the productivity of capital, the marginal productivity of capital, is what we get from one more unit of capital being added. Well, that's the partial derivative of our production with respect to K. So we have a brilliant mathematical formulation of these important economic ideas. Now here's the fun part, tying math back into the economic theory. At the optimum values of W and K, which we found before, we found W should be 240 and K was 40. Take a look at the ratio of the marginal productivity of labor to the marginal productivity of capital. Okay, so this is from earlier, but now we're asked to compute things about the marginal productivity of labor, so that Q with respect to workers, and likewise the marginal productivity of capital, that's our partial derivative of Q with respect to K, starting with our function, which was 6 W to the 3/4 K to the 1/4. Okay, so we compute these partial derivatives, and what do we get? Well, we get QW is 6. We've actually done this before. We bring the 3/4 down, and we get W to the 1/4 times negative 1/4 times K to the positive 1/4. And the capital derivative is the same. This is all constant. We just change how we handle the K factor, and we get K to the negative 3/4. Let's take one further step. And take a look at the ratio of those two things. The ratio of marginal productivity of labor to the productivity of capital. So the ratio of QW over QK is equal to this over this. So 6 3/4 W to the minus 1/4 K to the positive 1/4 over 6 W to the 3/4 1/4 K to the negative 3/4. So this is an economics idea where we say, well, which is more important, or what's the scale of the importance of workers relative to capital at a certain production level? We can capture that with a ratio. If this ratio is big, then workers are more important. If it's small, then capital is more important. But we can calculate that as a value. And if we do that, we get lovely cancellations happening. We end up with 3 W to the 1/4 times this. That's going to give us a W in the bottom to the power 1 by the time we're done. And K to the 1/4 divided by K to the negative 3/4 is K to the 1 on top. We're interested in evaluating this at W equals 240 though, and K equals 40. That's our current production. And if we do that, we end up with 3 times K, it's 40, over 240. And that is a ratio of 120 to 240. It's a ratio of 1 to 2. Okay, interesting. What the economic theory tells us, though, is that that ratio of 1 to 2 is also related back to how much it costs for each of those things. We're also asked to compare that to the ratio of the cost of a unit of labor to the cost of a unit of capital. Cost of labor was $10. Cost of capital, 1 unit of capital, was $20. And guess what that ratio ends up being? $10 over $20, also 1/2. These are the same, and that is not a coincidence. That is something that you can actually prove is going to be true in the general case if we are allocating our resources optimally. If we use the optimal labor and capital division or capital assignment. So that is a fun little tie-in to economic theory, and it comes back to our calculations based on the gradient vectors and Lagrange multipliers for these kind of constrained optimization problems. Now, we certainly don't expect students to be able to prove this kind of statement at this stage in the course, but we do expect you to understand what the marginal productivity of labor is and why it represents or can be represented as a partial derivative, likewise for capital, and to be able to understand what the ratio of a unit of labor to a cost of a unit of capital would look like, simply a regular ratio, and see that these two values line up nicely and recognize that when it occurs. That'll be the important message for this portion of the course, along with the actual process of identifying the optimums using Lagrange multipliers.